Here's a recurring nightmare. Guess what? Since exponentials are functions, you can transform them. You can transform them. But wait a second. Because I can transform them, are they any different than any other function? No, they're just like the other functions. So in other words, you can stretch them, you can flip them, right? And you can translate them, move them up and down or left and right. Are they based on another formula? No. Look, take your basic formula. Y equals to whatever that number is. Let's say it's 2 to the power of x. Look what we're going to do. If we're going to stretch it vertically, we have to have some factor up front. If we're going to stretch it horizontally, this better have a b here. If we're going to move it left and right, we're going to put an h here. If we're going to move it up or down, we're going to put a k here. And look where the emphasis is. The emphasis, of course, is going to be on a, right? There's the horizontal emphasis right there. The b value and the h value. The k, of course, is horizontal on, or I should say, is emphasis on the vertical. That's one of the reasons why the alternate formula could have the k on that side. Well, that just makes sense, right? So the basic shape remains very similar. You can stretch it or translate it. And you can even flip the darn thing if you want it. So in other words, you can have your standard graph going like this, or maybe you can flip it and have the graph going down like that. Maybe you can translate it. Instead of having the standard graph over here, you could actually put the graph over here. Move it around, stretch it all you want. But the funny thing is about all of this nonsense is that it's all based on everything that you've done already. It's really, really awesome. Yes, there's the formula. There's the formula. All the stretches are there. All of the translations are there. All of the reflections are there. You just have to remember SRT, the order because of bed mass. So A is still a vertical stretch. B is still a horizontal stretch, and you still have to flip it. H means right if it's positive, left if it's negative. K is up when it's positive, down when it's negative. And the cool thing is because this is an exponential function and we have a horizontal asymptote that's usually 0, when you're moving it up, guess what? So does the horizontal asymptote. That moves up as well. Yes, don't forget that they have to be in, guess what? SRT, stretches first. Reflections, translations, oh my goodness. Come on, let's just go do an example. Okay, consider the base function, and for each transformed function, state the parameters and describe the corresponding transformations. That's easy. Identify your A, B, H, and K, and you're off to the races. Sketch the graph. Okay. Describe the effects. Perfect. State the mapping notation. Okay. So here we go. The graph I want to deal with is this guy right here. Remember, its original graph was this guy. Y equals to 1/4 to the power of x. As a matter of fact, why don't you go out and graph that right now? You're smart. You know that that x, when it's 0, right? Any base to the exponent of 0 gives you 1. That's why that's always the key point to deal with. That's going to be just so important when we're dealing with this. Okay, so here's my graph, right? There's my 1. Now remember, the rest of this graph was y equals to 1/4 to the power of x. So think about this. When x is 1, this is a quarter. It's way down here. When x is -1, the negative means to flip this guy, and it becomes 4. That's why we've got the 3 points sitting right here, 1, 2, and 3, and we can accurately graph this. Now, let's apply the transformation. Woo! This will be fun. Check this out. The A is 2. What's the B value? Remember, B value has to be up here in the exponent now. Well, there is no B value. Well, actually, there is. It's 1. Your H value, how much did you move this? I moved, this is a -1, so I moved it 1 to the right. 1 to the right, because remember, it flips the sign. Your k value, there's no k here and there's no k on this side, so k is actually equal to 0. Oh, okay. So horizontally, what have I done? Horizontally, all I've done here is I moved 1 right. Vertically, what have I done? I've stretched vertically by a factor of 2. Nice. Okay. So let's look at our wonderful transform point, shall we? Okay. The best point in the world to transform is 0, 1. You might, at this point, just want to go out and do the mapping for this. It makes it so much easier if you do the mapping. So I'm going to go right down to the bottom here and go to my mapping notation right off the bat. Think about this. My mapping notation says take my point, x, y, and transform this. Remember, my b was 1, so it meant nothing. But I did move 1 to the right. So all of my points are going to be x plus 1. My y value is stretched vertically by a factor of 2. So all my y's are going to be stretched vertically. So check out the point 0, 1 and what happens to it. So 0, 1 then transforms to x plus 1, which is, guess what? It's going to be 1. And 1 times 2 is going to be 2. My new point is going to be 1, comma 2. Well, that's really, really easy, isn't it? Okay, so with that point being 1, comma 2, check this out. This point now becomes 1, comma 2. That's this point here. But how about my next 2 points? How about this point here? Let's transform that one. Sure, why not? I need some more room. Remember, this was negative 1, 4. Let's see how this one transports. Okay, here we go. This is going to be negative 1, comma 4. Here we go. This becomes, oh, look at that. Negative 1 plus 1 gives you 0. There's my new intercept. 4 times 2 is going to be 8. My new intercept is going to be at 0, 8. Let's plot that in there. Look how pretty this is. Oh my goodness. Okay, so let me get rid of this. It's at 0, 8. Nice. Well, how about this point here? Remember, that was 1, comma a quarter. Look. Okay, 1, comma a quarter. Let's see how that one moves. Okay, 1 plus 1, that becomes 2. 2 times a quarter is a half. Okay, so my new point is at 2 and 0.5. There's 2 and 0.5. Well, a half looks like it's about here. Right on. Look at my new graph. My new graph is just going to come down from here, along here, and move along here, and away we go. Now, here's the other cool thing. Here's the other cool thing. What you got to remember here is that, remember, this value was k was 0. So look where the asymptote is. The asymptote hasn't changed from the original graph. It's still an asymptote of y equals to 0. So, okay, let's go and do this. Transform points, we do all the transformations down here. Domain, think about it. Your x is still an element of R. Your range is still, because you haven't moved this up, your asymptote is still going to be x has got to be greater than 0. Not equal to, it's got to be above 0. Okay? Equation of the horizontal asymptote, of course, is going to be y equals to 0. But now, x-intercept. We still don't have an x-intercept. That does not exist because we haven't crossed the x yet. Okay? Your y-intercept, we just figured it out right here. Now, what if I wanted to figure out the y-intercept from the formula? Now, if you remember the formula was this guy right here, was y equals to 2, 1/4 x minus 1. Now, think about this for a second. Hold on. We know that a y-intercept happens when x equals to 0. So that means this guy's now 0. So if you think about this, this is y equals 2, 1/4. 0 minus 1 is minus. Oh, look at that. Knowing a little bit about exponential notation and exponential stuff that you learned way back in Math 10C, you know that this gets flipped to 4 over 1, or just plain old 4 to the power of 1. 4 to the power of 1 is 4 times 2. Look at this. Y works out to be 8. Wow, sweet. So what we drew up here, and part of our mapping notation, was we determined the intercept to be 8. We were correct, even algebraically. So our intercept is 8. This is how you do these questions based on SRT. Isn't that beautiful?